Welcome to the coding interview problem. Rotate array. You're given an array. Rotate the array to the right by k steps, where k is non-negative. We have to solve this problem in linear time complexity and in constant space complexity. You might think this problem a little bit critical to understand, but don't worry. I think it's simple. It's pretty simple problem. Don't worry, we will see how we can solve this problem. For example, if you're given this array as input and k equals to 2. Now we have to rotate this array by k step. So k equals to 2, so we have to rotate this array by 2 steps. So this 4 goes to this position, 4, then let's remove 4. Now 3 will move right here. Okay, and let's remove 3. Now what do we have? We have this array 3, 4, 1, 2, and we did 2 steps, 1 step and 2 steps. Okay, so we have to return this array. If you are given this array and k equals to 6, we have to rotate this array by 6 steps. Okay, let's rotate this array by 6 steps. 4, let's move 4 right over here. Okay, and let's remove 4. So here 1 step, then let's move 3 right here, comma, and let's remove 3. Here we have done 2 steps, then let's move 2 right here. Okay, here we have done 3 steps, and let's remove 2, then let's move 1 right over here, and here we have done 4 steps. Okay, 2 steps left, and here let's remove 1 as well. Now let's move 4 right here. So we done here 5 steps, and let's move 3 right here, and we done here 6 steps, and we have to remove 4 and this 3. So here we get this array 3, 4, 1, 2. All right, so we have to return this array. Instead doing 6 steps, we can just do 2 steps. Why is that? Let's see. Okay, if we do 2 steps, then 4 will move here, and we'll remove 4, then 3 will move here. Okay, and let's remove 3, and here we have 3, 4, 1, 2. Okay, so we get this array by 2 steps. How do I know that if I do 2 steps instead 6 steps, then we get this array? And we can calculate that by using this formula, k modulo the length of the array. Okay, here we have k equals to 6 modulo, and the length of the array is 4, and that's equals to 2. When we see k is greater than the length of the array, then we will calculate the modulo in between k and the length of the array. And for this case, we get 2. So instead doing 6 steps, we can do just 2 steps to solve this problem. All right, let's take another example. If you're given this array and k equals to 3, and let's move 7 right over here, 1 step, then remove it. Here we have 6, so let's move 6 right here, and here we do 2 steps. Let's remove 6, and let's move 5 right here, and here we do 3 steps, and let's remove 5, and this is the array, and this is the rotated array by k steps from the right. Okay, so we have to return this array. Hope you have understood the problem statement. Now let's see how we can solve this problem. This is a pretty simple problem. To solve. Don't worry. Some people think this is pretty abstruse problem, but I think it's pretty easy if you understand the intuition. Now let me go through the intuition. Let's assume we're given this array and k equals to 3 for sake of understanding. Now what we're going to do is that we're going to reverse the entire array. If we reverse the entire array, then we get this array. Okay, this is the reverse array of the given array. Now what I'm going to do, I'm going to reverse the k element from the start. Okay, if we reverse the k element from the start, then we get this array. Okay, now what we're going to do, we're going to reverse the rest of the element. Okay, if we reverse the rest of the element, then we get this array, and we have to return this array, and this is our answer. So what we have did, first we reverse the entire array, then we reverse the first k element, then we reverse the rest element, then we get this array, and this is our answer array. And this is the rotated array by k steps from the right. And this is the intuition. First we reverse the entire array, then we reverse the first k element, then we reverse the rest element, then we get our answer. And this is the intuition. Okay, this is pretty simple problem. Now let me analyze the time complexity. The time complexity for this problem, big O of 3n, and that's equivalent to big O of n. So this solution runs in linear time complexity, and the solution will take constant space complexity since we're modifying the array in place. Okay, now let's see the code for this problem. Now we're going to write the Java code for this problem. First, k equals to k modulo nums.length. If we find k is greater than the length of our array, then what we will do? We will calculate the modulo in between k and the length of the array. Then we're going to reverse the entire array. Reverse, this is a function that we'll implement, and it takes the given array, and we're going to reverse the array from index 0 to the index length of the array minus 1. Okay, then we're going to reverse the first k element. So reverse nums from 0 to k minus 1, and here this means the indices. Okay, then reverse, and here we're going to reverse the rest element. So nums from k to nums.length minus 1. Alright, now let's implement the reverse function. Private void return type void, then reverse. It takes an array and 2 integer. Let's call it start and end. Now while start is less than end, and this is going to be a simple programs to reverse an array. Okay, first temp equals to the first element in that array, nums start, then nums start equals to nums end. So we're going to replace the start with the end. Then we're going to replace the end with start, since here we have modified start already, and for that we have stored the start to this temp variable. So here just a temp. Then here we're going to increase start by 1. So we're going to move start to right, and then we're going to move end to the left. Alright, and this is the solution to this problem. Here we have return type void, so we have to return nothing from this function, and we're just modifying the array in place. Okay, the time complexity for this problem is big O of n, and space complexity for this problem is big O of 1, that is constant space complexity. because here we're not using any additional space. And actually time complexity is 3n, and that's equivalent to big O of n. Now let's submit this code and let's see if it works. Alright guys, we have solved this problem, and our code is faster than 100% of Java online submission. Alright guys, this is my solution to this problem. Hope you have understood this problem. Thanks for watching this video. I'll see you in the next video. Till then, take care.